Okay, so today we are going to continue, the unit testing of our calculator application. So let's revise what we have done so far, in quickly in a minute or two. So we have here, calculator class implemented. In this class, we have implemented our addition function. The purpose of this addition function is to take the two numbers from the caller, add the two numbers and return the result back to the caller. So this is the function written in our calculator API class. This class we have written in src test java, which is assumed to be the default source directory in a Maven project. And we have also written unit test cases in this src test java directory. So this src test java directory basically contains the unit test cases on our addition functionality. So in this test class we have implemented a method, this create obj, which is the prerequisite for all our test cases, because in the test case methods we are going to call a addition function written in our calculator class, right? So we are going to test this addition function with different data, combination of data basically. So we need the object of our calculator class, so that is what we are having here, and this particular method is annotated with the test ng annotation called before class. So before class annotated method gets called very first in a test class. Then we have implemented here two test case methods. So this is test case method 1, where we are testing the addition with two positive numbers. So here I am calling the addition method with two positive numbers, getting the result back, storing it in this variable, and here I am checking whether that result is according to the expected or not. So this assert equals basically checks the actual result with the expected, and if this fails, the actual and expected comparison fails, then this particular message, it puts it into the report of our test engine, right? Similarly, we have implemented this test case also. Now we are going to continue with the implementation of our rest of the test cases. Now here in this test addition with 0 numbers, here we want to test addition function if both the arguments we send to it are 0, right? 0 numbers. So in res calc dot addition, so 0, 0, and we want to check if the addition works fine if we send both the arguments as 0. Now we will assert, so I'll just copy this statement and put it here, and we want this res to be 0, right? So the actual result res should be 0, the expected is 0 here. And if it doesn't work, like if this comparison is failed, then we want to put a message in our log that addition is not working with both the numbers, when both the numbers are 0. Now if you see here, we need this res variable everywhere. Like this res variable is basically taking the result from the addition, and then we are checking the value of that res. So instead of basically defining this res variable in each method, what also we can do is we can define it at the class level, so that it needs to be defined only once, and then we can use it everywhere. So we don't need to define it in every test case method like this. We can simply use it, because this res would be now available for every test case method, or rather every method from this class. But there is one point here. Now if I define this res variable at the class level, so what will happen is, like when my test case first would call, okay, when this would be called, my addition would be called with 30 and 50, so I'll get the result back, that is 80 here, and then I'm asserting if that result is 80 or not, right? So I'm getting the result back from the addition. Now this res, now when my second test case would be called, this one, so my res will still hold the result of my previous test case. Okay, so this would still be hold here. Like once this cal dot addition would be called with the new data, then I'll get the new result back to the res. But this res will always hold the result of its previous test case. Now can we do something where I want this res to be set back to 0 before I call a new test case? So once this test case is done, its execution, before I call the new one, the next one, I want this res to be set back to the 0. So can we do this? So yes, we can. So what we will do is, we will have one more method, public void set res to 0. And when do we want this method to be called by testng? What is our requirement? Our requirement is, once the calling of a test case, a particular test case is done, now before my testng calls the next one, I want this res to be called before every test case is called, so that I will have this res set to 0, right? That is what my requirement is. So we will set res to 0, and when we want this to be called by testng, we want testng to call this before every test case, right? So I would say before method. So what this before method is, in testng, before method gets called before a particular test case method gets called by testng. Now let's understand the flow of this. So when we will run this test case class, what will happen? First, this method would be called, which is annotated as before class. So we will get the object of our calculator class created in this variable. Now next, what testng will do? It will start calling our test case methods based on the priority set, right? So, but before it calls a test case method, before it calls the test case method, it will first call this method annotated with before method. So what will happen? It will call this before method. We will have our res variable ready by setting it to 0. So it is now ready to get the result of a first test case, right? So then this @test priority 1 would be called. So this test case would be called. We are calling here addition with two positive numbers 30, 50. We will get the result back here. We will check that result if it is correct or not. Now testng will call the next test case method, but before it calls the next test case method, that is this one, it will again call this one and get our res set to 0. So this res will again be ready to take the return of a next test case, right? That's how this before method works. Basically it gets called before every test case method by testng. Now next, our next is we want to get our addition tested with two negative numbers. So let's say res calc dot addition I am calling now. So I am calling now this addition with two negative numbers. So I would say -10, -20, right? And then I want to check if the result is correct or not. So now this -10, -20, right? So we will get the result. Let's say we are having issue here. Let's say like I want to show you like how testng shows if a particular test case fails, then how it shows. So I'm just making a mistake here. Let's say I will say 30 for example. Now if the actual and expected don't match, then I want to say addition is not working with two negative numbers. Then what we want is we want to test addition with one zero and one non-zero number, so that we want to check that if the addition works well there in that case as well or not. So calc addition. So we want one of the two arguments to be 0 and another one to be non-zero, right? So I would keep the first one to be 0 and say 200. Okay, so then, and I will check if the RES gets the correct result of 200. Now if this doesn't work, then I want to put a message in the report that addition is not working with 1 0 and another non-zero. Okay, this is what I want to put. Now let's run this, and now we can run this. How can we run this? So we have to go to the POM XML. Inside the POM XML, we will right click here on the POM XML basically, and we would say run as and Maven test. So what this will do, this we have already discussed, that Maven will perform all the prerequisite life cycles along with the test. So Maven will download the required dependencies, plugins, whatever it needs, right? Then it will compile. You can see here in the logs itself. Okay, and then finally it will execute the test cases. So it still says that tests are only two tests got executed because on the top of these methods we have not annotated them with that direct test. That's why test end didn't call it. So I'll say direct test. I'll set this as priority 3. Then I would set this as priority 4 and this as priority 5. Okay, now let's run the test cases again. So again, let's go back to the POM XML, run as and Maven test. Right, so we have got the test cases executed. Now you can see there are 5 tests got executed. 1 is failed, 0 errors, 0 skipped. Okay, now let's see which test case is failed. You can just scroll up and you can see here that addition is not working with 2 negative numbers. So what is expected there? 30, but found minus 30. So basically we just, we know that, I have deliberately just make this particular test case to fail. Now let's see the report also now. The HTML report, how does it look? So let's go to our project directory. So what you can do is you can go here to your project, you can right click here, properties, and you can just open this in the Explorer. Here calculator API, then target. Inside the target folder you will see one folder called Surefire reports, and inside this you will see a report of our test case execution. So I'm just opening that report. So here is the report. So you can see here 4 test cases are passed, 1 is failed, right? And you can see the consolidated report of the execution here, and here you can see the message, right? This is the message which is coming from here. I would show you that. 2 negative. This is that message. I would say with 2 negatives, right? So this is that message which we are getting there in the report itself, right? So now as soon as any of the unit test fails, now developer, what he will do is he will check what is wrong, and accordingly he will fix the bug. Let's say if there is any issue with the functionality itself, so he will fix it, that problem, and then he will run the test case, the unit tests again. I'll just correct this. Now that in our case there was no issue in the logic of the function. We just deliberately made it fail just by providing a wrong expected result. But I mean the issue in real time issue could be in the logic of that particular functionality itself. So developer will fix it and he will rerun the tests. So again he will execute the unit tests by right clicking on pom xml run as, and he would say Maven test. Now you can see 5 tests run, no failures now. All the tests are executed well. I'm just refreshing this. Now we can see like all the tests are passed now, right? Now another point is like currently we just saw like how to trigger the tests from our Eclipse. Now let's see how can we trigger different build life cycles. We saw triggering different build life cycles like compile, then clean, and different life cycles through Eclipse. Now let's see how can we trigger different build life cycles from command line. Now this is going to be very important, because as I had already mentioned that we are not going to use Eclipse for triggering the build life cycles or triggering the build for that matter. We are going to write our pipelines, right, for that. But before we go and start writing the pipelines or look into the triggering of the build life cycles from pipelines, we should know how to trigger them from command line. Now let's see how to do this. So I'll just open a command line. We already have Maven set. So this is the prerequisite to use Maven from outside of the Eclipse. To use Maven from inside the Eclipse, you don't need to do anything explicitly, because Maven comes along with the Eclipse, latest versions of the Eclipse. If you are using a too old version of the Eclipse, something like Luna or something, then you need to install Maven plugin the way we did it with test engine. Otherwise, with the latest versions of the Eclipse, you will find Maven already installed in the Eclipse. But if you want to use Maven outside of the Eclipse, then we need to install the Maven, which we already have done. So we have Maven here downloaded and unzipped. We had configured few environment variables which you guys are already aware of, that we have m2_home environment variable which points to this location, and we have added also the path of this bin folder inside the path environment variable. So these things we have already done. Also we have set the java_home environment variable which points to our JDK location. So these things we have already done, and we are all set to use Maven from command line. Now before you can trigger the Maven goals or different build life cycles, what we need to make sure is that you need to be inside the project directory, meaning for triggering the Maven build life cycle, your working directory should be your project directory. So we need to be inside this directory in the command line. So I'm just changing the drive first and I'll change the directory. Okay, now my working directory is my Maven project directory. Now from here I can trigger different build life cycles. Now let's say if I want to say Maven clean. So what this MVN clean will do, it will delete the target folder, which is a output folder. Now first it will download all the required plugins for it to perform that clean operation, and then at the end, if everything goes well, you will see build success message. Now let's see what has happened with this. So you can see here in this calculator API, our project, this is our project directory, right? Calculator API. Inside that there is no target directory now. This is what the Maven clean does. Now let's execute another mvn compile. Okay, so let me clear the console. Mvn compile. So I am asking Maven to compile the sources. Mvn compile. Let's run. So it will first download the required plugins if they are not there. Okay, now there is an issue here. So you can see the issue is compilation failure, and it says that source option is 5 is no longer supported, use 7 or later. So there is some issue in the version of the compiler it is using. We will fix this, that's not a problem, but let's see what it has done so far. So it has actually downloaded the required things, right? And then it has started the compilation of our source code. Okay, it has started the compilation of our source code. Now let's go and check. As the compilation is not successful, so inside this target folder, let's go and check classes. So there is nothing here because the compilation is not done successfully. That's the problem. So here you will not see anything. If once the compilation is successful now, we will see inside the classes folder, we will see the class files for our application source code, and in the target folder we will see one more directory called test-classes. Inside that we will see the class files for our unit test cases, right? So now let's see this issue. What is this problem? So the problem is, let's see what is the version of our Java. So it's 1.8, JDK 1.8 it is. Now the source option is 5 is no longer supported is what it is saying. So the problem is, let me go to the POM XML. But our compiler source is 1.7. Okay, just a moment. Here 3.8. Let me see if there is any configuration here. So you can configure the plugin accordingly. So I will just say configuration. Configuration. yeah, compiler source. So I will just change the source to 7 as it has. By default it uses 5, so we need to use 7. I'll just make the necessary changes, and now let's see the compilation. Okay, no, still it is taking this. Okay, let me see the fix of this issue. I'm not sure why it is giving us this error. So many a times, like now this is again real-time thing, that many a times whatever the issues you fix, whatever issues you face, you need to look for the solution of it, right? So let me see the latest Java environment. Okay, we are anyways using latest Java environment. Maybe our projects let me see the issue here in the let's see what it says. Okay, it says that, now also understand this, when you say something like this, no, project configuration is not up to date with the POM XML. Okay, so what you need to do is, if you see something like this, what you need to do is go to the project, right click and go to this Maven and say update project. So it will update the project according to the recent changes in your POM XML. Let's say force update and click OK. Okay, so now there is no error now, you can see it, right? Let's see if this fixes our issue. No, still not. Okay, we need to do some changes into the JDK. Let me see the JDK which this particular project is using. It is using 1.7. You see here, the project is using JDK 1.7. That is the problem. Now let's see how to solve this problem. I will show you now. Let's remove this JRE. Okay, apply and close. And what we need to do is, we need to check what is the Java installed along with this Eclipse. How can you check? Go to the preferences. Now go to the Java here. Inside here, go to the install JREs. Now you can see there is a JDK 1.5 there, installed and configured with Eclipse. Now we need to add this JDK to our project. So our project was having 1.7 and that was the problem. So how to add? Go to the build path, configure build path, go to the libraries, click add library, select this JRE system library, click on next, and here you will see the JRE. This is the 15.0 rather, that is JDK 15 is the one which is set. And now let's add it to our project and say apply and close. Now there won't be any issue. Still it is okay. Just a minute. Let me see the JDK 15, it is correct. And close. Let me just say MV and clean. Let me clean this. Yes, someone has raised their hand. Yeah, I'm making changes in Eclipse. Yes, I know, but I'm just checking from the Maven POM XML source compiler. Okay, let me correct. Let me change the uh, here 1.7 instead of that. I'll do 1.8 compiler 1.8 and we should be fine. No, still it is not taking that option. Is something which is okay. Let me see. There is some mistake. I would say JDK 15. I would say. Source option file is no longer supported. That's fine. But which compiler plugin it is using? It is using 3.1. Okay, and which compiler plugin I have asked it to use? Okay, just a minute, guys. There is some issue here. Let me just remove this and just yeah, it is not using this compiler plugin versions actually. Let me just remove this. Okay, and let's just a second. There is some issue with the compiler plugin, but I am asking it to use this compiler plugin. Just wait. Let me see the changes which I am doing is the correct directory or not. Just a minute. Oh sorry, I am doing the changes in a different directory. Sorry. Inside this, I mean our calculator API is this one actually. So we should be inside this file. Okay, I'll remove that another project. Yeah, okay. Yes, we are good here. Yeah, that's what I was wondering, that you can see here. It is using 3.8 compiler version, the plugin. We have got it here also. But for that another project, it was using the compiler version 3.1.0, whereas we have it 3.8.0, right? So that's what I was wondering, like how it is using 3.1.0. So let me just control set. Now let me remove that another project. That actually we created the confusion. Okay, everything is good here. So let me first go and remove that calculator API project from here. Yeah. So our project is this one. Okay, so in our calculator application, this is our project. This is the project directory. So project directory always is the directory which contains the POM XML. That is the project directory for a Maven project. Okay. So you should be always inside the project directory to trigger different Maven lifecycle phases. Okay, so inside this, now let's run it once again with the build cycles. So I would say mvn clean first. So this mvn clean will clean the target directory. You can see that here there is no target directory now. Mvn compile. So after mvn compile, you can see the target directory created. Inside the target directory, you can check a folder called classes is there. Inside the classes folder, you would see the package directory structure, and inside that you would see our calculator.java has been compiled into calculator.class. Right? Now let's trigger the next phase, mvn test. So as soon as I will do mvn test, it will first trigger the compilation of our unit test cases. Compilation would be done first, and then the execution of the test cases. Mvn test. Right, now you can check here inside the target, you will see test-classes created here. Test-classes. Now what does it contain? This test-classes folder contains the class files for our test cases. The way our application source gets compiled and class file gets created, our unit test cases gets also compiled. So this also .java file gets compiled, right? So you will see the class file for that Java file here. Here it is. And our tests also got executed, and the report you can see here inside the target. You will see surefire reports, and here you would see that in the surefire reports you would see the report generated. Right, now let's trigger another build phase, that is package. So as soon as I will do package, it will execute all its prerequisite phases. Now you can see here it is not only executing package phase, it is also executing the prerequisite phases, like I will show you here. Let's go up and see. See here, it will first trigger the resources plugin, which will download the required resources. It will trigger the compilation of our application source code. Then it will trigger, let's go down, and here it will trigger the compilation of the test case code. That's what you can see here, the task. This is the task, name of the task. So for compilation of our source code, the compiler is used this one, and the task is compiled. So this compile task will compile the source code, and the compiler plugin task test compile, meaning compile the unit test code, right? And then we are triggering our execution of our test cases using surefire plugin, right? And once the test cases are successful, all are passed, it will move ahead with the package phase. Package phase will create a jar file. Do you see here? It says that building jar, and the calculator API jar has been created. So let's go and check our target folder. So inside the target folder, you would see calculator API jar created. Now where does it got its name from? So the name I had shown you that day as well. The name, this is the name, calculator API. If you want to change the name of the jar file, then you have to change this. I will just change this here, calculator. So now our jar file name would be calculator. And where does it get its version from? This is the version. You can see here 1.0. It is getting it from here. So let's trigger the build again. I'll say CLS and I would say MVN clean, and then I would say package. So first it will clean, will run the entire build life cycle. Correct. Now let's check out our target folder, calculator API. I would make this. Now let's see one more thing. Now this is the target folder and here we have got the calculator API. Now let's say if I want to change the version of my calculator API, let's say if I add few more functionalities and want to release a version 2.0 for example. So we have to make a change here, 2.0, and we will trigger the build again. So here you can see calculator API 2.0 has been generated. Right? This is the calculator API 2.0. Right? So it basically takes like few Maven versions, like the version which we are using currently. It is not taking this name actually. It is, but like the older Maven versions, they used to take the name of the jar file from here, but this Maven version is somehow not taking it from here. It is taking the artifact ID only. So with the artifact ID as a name, it generates the jar calculator API, and the version it is taking it from here. I'll show you when we need to update this version, when we will add few more functionalities in our library. We will release version 2.0 of it. Then after adding further more functionalities, we will release 3.0, 4.0. That way you can release different versions of your library. Now let's talk about another goal, that is MVN install. Now what is this install? Okay, so what this install does, let's see. MVN install, it will first perform all the prerequisite lifecycle phases like compilation. I will show you again. Let's go up. It will perform again downloading the resources, compilation of our source code, then compilation of our test cases, test case code I mean, execution of the tests. Once all the tests are executed fine, it will perform a package phase. For that it will use jar plugin and it will create a jar file, and then it will install that jar file. Now what do we mean by install? Let's see. So what this install does, it installs our jar file, this jar file. It installs this jar file. Let me delete this to avoid the confusion. Currently we are working on 1.0. Okay, so this will install this jar file in Maven's local repository. Now what do I mean by that? A local repository in your C users, that is current user directory. For me it is another D. Inside this you will see the .m2 folder. Inside this you will see a repository folder. This is the local repository, right? This is where Maven downloads all of the required plugins, all the dependencies and all. So this Maven install basically installs our jar file in this local repository. I'll show you where does it install it. So what is the group ID of our library? DevOps batch 1. So it has created here a folder called DevOps batch 1. What is the artifact ID of our project? Calculator API. So it has created a calculator API folder here. What is the version? 1.0. So you'll see it has created a version 1.0. Okay, and inside this you will see a jar file has been installed. Now you might ask, okay, why do we need to install the jar file in the local repository? What is the need of it? Now, if you have any other application, like this is the library application, and if you have any other project which is consuming this library, which is using this library, it's calling the functions from this library like addition, subtraction, multiplication, division, whatever the functionalities we will implement here, that consumer application will use this library and will call the different functionalities implemented inside it, right? So that project, the consumer project, that project will take the jar file from the local repository. Maven will add, I will show you like how can we add the library in our consumer project. So one project is our library project, so which we are developing, we are unit testing, we are packaging, we are releasing, and another project is a consumer project which is consuming the library and using different functionalities implemented in it. So that consumer project will take the library from this location. Okay, that is what the install is. We will see it definitely. We are going to see it, that how to consume the library, but that is what the install is, right? It installs the library in the local repository and deploy. So there is one more, deploy. Now what this deploy does, it doesn't install the library in the local repository, but it deploys it onto the remote repository, that is a repository like this. Now we are going to configure Nexus as our remote repository. We are not going to deploy anything on this NVN repository, but we are going to deploy our library on remote repository. So if the consumer of these libraries, like if you install the library in your local repository, then the projects from this machine only can consume it. But what if your consumer projects are on different machines, so you want that library right there on those for those projects there, so you need a remote repository actually, so from where those projects can download those libraries and they can use it. So installing the library in the local repository is not that much useful unless you have the consumer project on your system where that library is installed. That's fine. But if you have consumer projects on different systems, then installing the library in a local repository is of no use, right? You need to deploy it on some remote repository. Another point which I want to make here is like when you run any, say a package, any goal like package, we know that it runs all the prerequisite goals, like it compiles the source code, it compiles the unit test code, it triggers the unit test cases, and then it moves on to the package. Now if any of the prior phases fails, like now I am asking it to package my library, so it will, as a part of the execution, it will trigger my unit test cases. Now if any of the unit test fails, okay, if any of the previous phases fails, that Maven doesn't perform the phase you have asked it to perform. Let's see this. I'll show you this now. Let's go to our unit test case. and I will just do some change here. Let's say I will change the expected result of this test case to be 160 so that it will fail. I want just this test case to be filled, nothing else. And then let's run package. See, now our test case is failed. You can see here that test case, there are 5 tests run, 1 got failed, and this is that failed test case. Okay, now you will see that it has not packaged my library. Okay, it has not moved on to the next phase. So as soon as any phase fails in your build life cycle, Maven stops the life cycle there and there itself. It doesn't move on with the next phase of the build. If your compilation fails, let's say compilation of your application fails, then Maven will not move ahead with the test phase, right? If the test phase fails, it will not move ahead with the package phase. If the package phase fails, then it will not move ahead with the next phase, like install or deploy, right? That is how it works. So you will see here in the target folder here, let me clean this so that we can see. So I'll say Maven clean package. So clean will first clean the target directory, and then the entire build life cycle will run. So the execution of the test failed. Now if you go and check the target directory now, there is no jar file created because the unit test phase failed. There is some failure there. So developer will have to go and check what is the reason for the failure. He has to fix it, and again he has to trigger the build. Now let's fix this and trigger the build again. CLS, and I will say Maven clean package. So it will first delete the target directory. It will compile my sources from scratch, and now the build success. Now you can see the package phase has created a jar file, and here is our jar file. Now if I say mvn clean install, so what it will do, it will, let me just clear the console and then clean install. So the clean phase first will delete the target directory. The install phase will run the entire build life cycle, will start with the compilation of my source code, then it will trigger my unit test cases, but before triggering the unit test cases, it will compile my unit test case sources, it will trigger the unit test cases. Once the unit test cases are completed and they are passed, it will move on to the next phase of packaging, and then it will install that in my local repository. mvn clean install now. Right, so it has installed the package here. You can see the timestamp for this. It's 8:41, and currently the time is at just, it has changed to 8:42, but this is the recently installed library here in the local repository, right? That is what install is. We are going to talk about deploy phase once we will configure our Nexus repository. So we will see what this deploy phase does in that case.